Hey you guys, I decided to make you a little video on the forms of equations that we are going to be using in class. You've already seen all of them, but it looks like you guys need a refresher. And I want you to get your notebook out right now. On your notebook, I want you to write on the top equations of lines and then make some room for 3 different equations of lines. You might even want to divide your paper into 3 different sections so that you have room to write about the 3 different equations. So there are 3 different equations that we are going to be using. These are the forms of linear equations. And remember, linear equations is one of our vocabulary words, and linear is like linear, remember? And it means it's a line, an equation of a straight line. It even says it in its name. So a linear equation is a linear equation. It's an equation of a straight line. And there are 3 forms that we use in this class to represent linear equations. Those are standard form, slope-intercept form, and point-slope form. And it's so important that you have all of these lodged in your brain and in your notebook so that whenever you see one pop up, you know what to do with it. Before we start talking about the different equations, I want to let you know that just like these 2 bananas are in different forms, we can also write equations in different forms without changing their value. Both of these pictures are of bananas. They're going to taste the same. They look super different, but their value is the same. They're both bananas. Nothing has been done to them except their form has been changed. And the same thing happens in math. You can write one equation 3 different ways, and it doesn't change its value. It just changes what it looks like. And you're thinking, well, why are you making it more complicated and using 3 different forms? Well, that's because each form is useful in its own situation, and we'll learn about that later. But today I want to introduce you to the forms so that you can get used to seeing them, and then later we'll learn about how we can use each of those forms. So first is standard form. This is the first form of the equation that we used in this class, and the general mathematical form is ax plus by equals c. And what that really means is the x and the y values are on the left-hand side. That's its key identifying factor. That's why we have standard form. It just means that the x's and the y's are on the same side. It's okay to have their coefficients with them. The coefficients are the little a and the b right there. Those are the coefficients. They're just the numbers in front of the variables. So here's 2 examples. So example 1 is 2x plus 4y equals 10. Example 1 has coefficients. So x's coefficient is 2 and y's coefficient is 4. That's okay. So if you want to see an equation that looks like this, it's in standard form. There's also an example number 2 where we just have x plus y equals negative 12. In example 2, it does not have any coefficients, and that's okay. They're both in standard form. So now we have slope-intercept form, and this is the most commonly used, and this is the most beneficial in Math 8. So the mathematical form for slope-intercept form equations is y equals mx plus b. Some things to remember are that the slope-intercept form equation makes it very easy to identify the slope and the y-intercept. Remember, in math, we don't try and trick you. We want to help you. So when we give you an equation in slope-intercept form, it's giving you a form where you can easily identify the slope and the y-intercept. Makes it very, very helpful. So in this equation, y equals mx plus b, the m represents the slope, the b represents the y-intercept. And then the x and the y, they stay there. The x and the y represent all other x and y values that exist. A key identifying factor of slope-intercept form equation is that the y is alone. So the y is a loner in this form. So whenever you see an equation that has just y on one side and all the other information on the other side, that can tip you off that it's in slope-intercept form. So here are some examples. We have y equals 4x minus 6. That's our first example. And in this example, our slope is 4. And our y-intercept is negative 6. Because 4 is in the nth position. It's being multiplied by x. And negative 6 is our additional value that represents the y-intercept. In example number 2, we have y equals negative 2x and then nothing. So what this means is that our slope is negative 2 and our y-intercept is 0. But in math, it's a little bit redundant to write plus 0 all the time. So we usually don't do that. We just write y equals negative 2x. And that's it. So if you see an equation that looks like y equals 4x minus 6 or y equals negative 2x, that is slope-intercept form. The y is by itself, everything else is on the other side. That's slope-intercept form. The third form of the equation that we are going to talk about is point-slope form. Point-slope form is an equation written in the form y minus y1 equals m times x minus x1. Here's some key things to remember. A point-slope form equation makes it easy to identify the point and a slope of a line or graph. Now, like I've said, we don't try to trick you in math. This is pretty self-explanatory. A slope-intercept form identifies the slope and the y-intercept just by looking at the equation. And a point-slope form does the same thing. It helps you identify the point and the slope of a line. So m in this equation represents the slope just like it does in slope-intercept form. And now in this one, we have an x1 and a y1. That looks a little bit different. And the reason why is because we need to distinguish the difference between this y and this y and this x and this x. So in all equations, we have an x and a y that stay put. We don't touch them or move them. But x1 and y1, that represents a specific point on our graph. And that point is a location where the line passes through the coordinate. So if you look at my little diagram over here on the left, this point, let's say this point is on this line right here. And it makes it really easy to draw this if I know this one point and its slope. So point-slope form is very helpful when we're graphing things and when we're trying to write equations from a graph. Here are two examples of equations written in point-slope form. You can identify that they're in point-slope form because they're kind of the more complicated of the three. You've got a y plus or minus something on the left-hand side, and then on the right-hand side you have the slope being multiplied by x plus or minus something. And the thing that determines whether you have y minus a number or y plus a number is the point that you're using. So in example number 1, the point that we're using, the x value is 4, and the y value is 2. So it's like I just deleted the y1 and the x1 and I just put a 4 in for the x1 and a 2 in for the y1. In example number 2, the point we're using is negative 6 and positive 4, negative 4. This seems a little bit counterintuitive, but you'll just have to remember that when you're looking at the equation, because you have a y minus a y1 to begin with, if you have a positive value and you put it in, you're going to have y minus that value. And if you have a negative value and you substitute it into the equation, you'll have an x plus that value. So you'll have to start remembering that if you see a y plus 4, that means the y1 value is negative. An x plus 6, that means the x1 value is negative, and vice versa. If you see a y minus 2, that means the y value is positive 2. And if you see an x minus 4, that means the x value is positive 4. So be sure to get that in your notes. This one is where people have a hard time because they get them backwards. But both equations are written in point-slope form, and they're pretty easy to identify, like I said, because they are the more complicated of the two, but they're very useful when we're graphing. So in summary, we've got three forms. Standard form is ax plus by equals c. It's not super useful, but it's best to convert it to slope-intercept form, which I'll show you in another video. Slope-intercept form is y equals mx plus b. It's the most useful form that we're going to use in Math 8. M represents the slope, b represents the y-intercept. Third, we have point slope form. The mathematical form for this is y minus y1 equals m times x minus x1. It's used most when we're writing equations from a graph or given 2 points. M again represents the slope, and x1 and y1 represent a coordinate on the line or graph. Hope this helps. Make sure you get it in your notes so that you got it for class next time. Have a good day.